Good evening, students. How are you? How was your New Year? Happy New Year. How are you? Everybody, all the centers. Good. Yes, I can see only one center online, Shillong. How was your New Year? Yes, children. Okay. Is that my class? Yes, 11th Bio. Happy New Year. Share your camera port number 8084. Okay, you have already shared. Yes, get up. 11th Bio. Is it? Okay, just wave back. Okay. So we were discussing movement and locomotion in the last class, and I talked about all these skeletal muscles and everything. Sorry, skeletal system. You can just go to the video and of the last class, and obviously you can just come back if it has any doubts. You have any doubts? Okay, it was excellent. The new one was very nice. Okay, fine, very good. Yes, one more center I can see connected. Who is it? Yes. Nice, very good. So you enjoyed. Now it's time to study. So we were talking about all the bones and everything in the last class. You can just go through the video, and obviously if you have any doubts, you can always come back to us with the same. And what I will be doing is that I will start the muscle section, the muscle part today. Okay? So movement and locomotion. So movement and locomotion is possible because of what? Because of two components. The first happens to be the skeletal system or the bones. So we discussed about that in the last class, and if anybody among you have any problem, you can talk about it, and again you can talk to me on the WhatsApp group as well as on the class also. So we'll talk about muscles today. So there are typical kinds of muscles we have studied since like our 7th standard. Like we have talked about voluntary muscles, which are also called as striated or skeletal or striped. And then we talked about smooth muscles or visceral muscles or involuntary muscles. And the third category of the muscles, which happens to be the cardiac muscles. So we divide the muscle types into 3 broad categories. The one which is important for this chapter happens to be the skeletal muscle or the voluntary muscle or the striped muscle or the striated muscle. So what we need to do is that we will start with this whole thing. That is so movement and locomotion, I will talk about muscles part today. So the typical category of muscles which help us in movement and locomotion happens to be the skeletal muscles, which are actually attached to the skeletal system, or better say the bone section, the bone part. So this skeletal system, these particular muscles, these skeletal muscles, they are also called as, okay, black is over here, voluntary muscles, since they are under your control, or they are also called as striated muscles. Yes, because they have striations. Or you can also call them to be linings, and also called as striped muscles. since they have stripes on them. So what was the stripes? What kind of stripes do we have on these muscles? Yes, let us see. Sorry. Which other center is logged in? Who is it? What kind of stripes? Stripes of this kind. Alternate banding. Alternate banding. So there is alternate banding when you talk about the muscles, this kind of muscles. This whole section from here to here is called as A band. And this whole section from here to here is called as I band. This part, this region of light colored zone, this light colored zone, is called as H zone, and this dark region in between the I band is called as Z line. So I have specified 4 things over here. What are they? First thing, I have a dark band called as A band. I have a light band called as I band. Obviously, all of them will be in alternation. Dark, light in this scenario. Now, my dark band has a light colored region between it. It is called as, H zone. What is H zone? H zone is the light region in the dark band. And what is Z line? Z line is the dark line in the light band. So we have all these 4 things. We will see now how these 4 things are appearing. Okay, we have these 4 things sorted out in this particular diagram. Let us talk about the sequence, the way how they are actually aligned. So if you talk about this thing, let's like just see what is the particular scenario. We'll just take 2 or 3 bands in alternation. Yes, I'll try to explain using this only. Let's see why is this thing happening. So what we have is these blue things attached on a single side of the Z line. These all blue things attached on the single side of the Z line. You can draw along with me. So we have these blue things, these blue structures attached on a single side of the Z line. So obviously this is from one side and another side. Again, next thing. green bands. Green thick bands. So over here we can again see Z line and this whole region is the I band. This thing is the Z line. So I band is what? I band is the region of only blue parts with a dark Z line in between, which performs as an attachment point to the blue line. This blue line is called as actin myofilament or thin myofilament. So you have two things. You have I band. I band is made up of actin myofilament or thin myofilament, and in between the thin myofilament you have a Z line. Now, next thing, when you talk about thin myofilament, obviously there must be something which is thick. Comparatively, it should be thicker. So you have next thing, this whole area is I band. Now, let us see the area of A band in this particular diagram. It will be same in that diagram also, but it will be a bit hodgepodge. That's why I'm trying to make it in this section. This is, here also it would be A band, but I'm avoiding to mark here since it will be making it more congested. So this area, this whole area where you have blue and green sections overlapping, this is called as A band. And this green particular thing is called as, obviously if it is thin, this needs to be thick. So that's why I have made it thick also. This is thick myofilament. And this is made up of a protein, like it was actin over there. This is myosin myofilament. This is myosin myofilament or thick myofilament. Clear? Are we clear up to this, everybody? Now, in between the A band, you have a light region. What was that? That was H zone. This H zone has, or we can say the myosin is held by a thin line. Myosin is held by a thin line, and that thin line is called as M line. If you are holding the actin with the help of Z line, you will be holding the myosin with the help of M line. Now, next thing. Distance between two adjacent. This is a Z line. This is another, again Z, the different Z line. Distance between two Z lines is called as sarcomere. Clear? This is the structure of the skeletal muscle, why it is striped. This is what is the reason of it being striped. If you want to mark the things as in the earlier diagram, like H zone, this would be the H zone. This whole region would be H zone. This is H zone. H zone. In between H zone, we have M line. Let's mark one more. First thing, what we have now, till now, I have taught you I band. So I band is having actin only. Then I taught you A band. This is actin plus myosin overlapping. Then we talked about H zone. This would be only myosin minus actin. H zone is what? Myosin only but without actin. You can see this. This yellow section is H zone. This yellow part is H zone. We have just marked it. It does not have actin. So myosin minus actin, where? In A band. It's called as H zone. Next, we have is Z line. What is Z line? Attachment of actin on one side. Then we have is sarcomere. Distance between two Z lines is called as sarcomere. Then, next thing, am I left with something? Yes, M line. Clear, everybody? Yes. Who is the other center online? Which center is online? Please let me know. Apart from Shillong. Yes, Tamilnong. Am I clear up to this? Shillong, Tamilnong. Are we clear? Yes, Tamilnong Center. Happy New Year. Good evening. How are you? How was your winter vacation? Yes, Tamilnong. Done, Shillong? Am I clear? Just give me a thumbs up. There's very, many of you have not come for the class, as I can see. How many of you are there for the class? Please give your attendance also. Both centers, Shillong and Tamilnong, please give us your attendance also. It must be cold over there actually. Clear, children? Yes, okay. So we learned many new things over here. I told you about A band, I band, Z line, sarcomere. So sarcomere is what? What is sarcomere? Sarcomere is defined as the functional and structural unit of contraction. So what is sarcomere? Sarcomere is the structural and functional unit of contraction. We'll see the process of contraction also today. Done? Clear up to this, everybody? H zone, M line. Okay, I'm moving ahead. Yes. Everybody, all of you. Shall I? No. This is the ultrastructure of actin and myosin, both the contractile proteins. We will see their ultrastructure now. Let's start up with actin. So how is actin? Actin is attached to one side on the Z line, somewhat like this, isn't it? So we'll start to have a diagram of actin in this similar way. So if you go through this ultra structure, if you try to magnify this, you will be able to see somewhat sorry. Do you know laddu? All of you? Huh? You must be. So these red things are, oh, I made one black laddu. So these red are what? These red are many laddus. So what you have to do is that you have to place many laddus into a particular sequence to follow a helical pattern. You have to have two sequences of laddus. Every laddu is called as G-actin. So what you have is you have many laddus, and those laddus are placed in this kind of pattern. Now each laddu is called as G-actin. The full form of G-actin is globular actin. Now these G-actin, they polymerize. We all know polymer, monomer. So this G-actin is a monomer. This is one laddu. What you are going to do is that you are placing many laddus in line, many laddus. So this whole structure of each G-actin, when they form a polymer, is supposedly said to be F-actin. This G-actin polymerizes to form F-actin. So F-actin is a polymer and G-actin is a monomer. So F-actin is what? This stands for sorry. Stand for fibrous actin. Now, along with this F-actin, there will be a line, a black sequence. You can see a black structure is also running. This is called as tropomyosin. Okay? This is called as tropomyosin, M-Y-O-S-I-N. So tropomyosin is again a kind of line which is running along with the F-actin. So the way F-actin runs, tropomyosin will also run. Then we have is, on this tropomyosin, we have many, sorry, what color can I take? Blue I will take. We have a trimeric protein. Can you see I am drawing 3 dots every time? So we have a trimeric protein I will be sending you some videos on your groups. So when you go back home, on whatever number you are logged in or to your WhatsApp account, you can see those videos also. I will be sending you 2 or 3 videos today. We have this kind of sequence. So this blue part is nothing, but this blue part is called as what? This blue thing is called as troponin. So what is this troponin? This troponin is a trimeric protein. If it's 1 unit, it is monomer. If it is 2, it is dimer. If it is 3, it is trimer. So what is this? This is a trimeric protein. What is trimeric protein? This consists of 3 subunits. consisting of 3 subunits. So this is the whole structure of the actin. Let's again revise. So you have one laddu. One laddu is called as G-actin, which is monomer. This G-actin forms a whole sequence of many laddus called as F-actin. You have 2 certain F-actin filaments which are helically running together with each other. Then we have is tropomyosin, which again is a fragment, which again is a particular thread-like structure running along with the F-actin thread. Again we have certain trimeric proteins called as troponin, which are placed at intervals on the tropomyosin. Now, this consists of 3 subunits. Each of the subunit binds specifically to a different part. The first subunit will bind, one of the subunits will bind to calcium ion. The next is going to bind to obviously tropomyosin. And the third is going to bind to actin. Or we can say fibrous actin, F-actin. Clear? Sorted up to this, everybody? Can we move ahead? Yes, Shillong? Tamil Clear? Just give me a thumbs up. I can hardly see you people because there is very low amount of light in your class. Or it's reflection. Can you just give me a thumbs up? It's clear. And Tamil please. Let me know if things are clear. Not able to see anything on Shillong Center. At Shillong Center. Yes. Just let me know if in case you are finding a trouble. Okay. It's very dark in your class. Clear? Can I move ahead? Yes, children. Actin structure is over now. So you have this kind of structure placed on the Z line. This is the Z line. This thing is Z line. So you have the Z line, and to Z line you are having what? You are having troponin, tropomyosin, F-actin. Together, actin is made up of these 3 things. So actin is made up of how many things? Actin is made up of 3 things. What are they? They are, number 1, F-actin, obviously which is a polymerization product of G-actin. Number 2, tropomyosin. Number 3, troponin. So you have 3 subunits placed under the same structure called as actin. I am moving ahead. Now, the second thing what comes is the green band called as myosin. So I will just try to make you understand something over here only. So this actin is somewhat, I guess it must not be clear to you. So you are having these kinds of loops over the myosin. Can you see this? Everybody? Can you see these loops? Can you see this? These black structures. These particular black structures I will be discussing now. How are they placed? So this myosin, as I told you, we'll talk about this myosin in somewhat this structure. This is my myosin, and it has loops of this kind. Can you see this loops, hook kind of thing? It's ultrastructure. So when you enlarge this ultrastructure of myosin, just elaborate it, what I am going to get is, if I just elaborate like supposedly these 2 threads, what I will be getting is So this is actin binding site. And this pink region is what? This has an enzyme called as ATPase, and this is ATP binding site, where the ATP will bind. So ATPase is an enzyme. We have done with biomolecules. Now you know what is particular enzyme's action. So just summarizing it over here, just ATP, when ATP is broken down with the help of ATPase, what we get is, we get ADP, inorganic phosphate, and energy. Just remember this equation. We'll come back to this very shortly. So you have this equation over here, and when ATP binds to this site, you need to break this ATP into ADP plus pi and energy by using the enzyme ATPase, which is present in the pink region of the myosin. Now this whole thing is very heavy. So it's said to be heavy meromyosin or HMM. This thing is light. So it's called as light meromyosin or LMM. So you have two things. First thing is HMM or heavy meromyosin, and second is LMM or light meromyosin. So you have two things over here. Heavy meromyosin, light meromyosin. Heavy meromyosin has two things again. One is actin binding site, which will bind to actin, and other is ATP binding site, which has an enzyme called as ATPase. Sorted up to this, structure is clear of myosin? Everybody? Yes. The structure of myosin is clear? Clear? No? Yes? Tell me something. So this structure goes somewhat like this. So this is going to bind on this thing somewhat. So your G-actin is going to bind to your myosin, and then the muscle contraction will take place. So are we clear up to this? I can move ahead with the contraction of the muscles. Done with structures. What? This thing? This is structure, children? See. What is this? This is actin. So you have many laddus over here. I'm just going to draw one of them, not both the filaments. I will just draw one of the filaments. Okay? And this is going to be attached to this loops. So what we need to do is that we need to make a cross connection or bridge between these two. We have to make a bridge between this thing to this thing. Okay? We need to make a bridge between this thing to this thing, this to this. So this bridge-like structure is going to help us in contraction. So what we have to do over here, we have to bind actin on this particular site, at this particular site. So this was this particular site. This is actin. So we need to bind actin at this blue particular point so as to make the contraction possible. Okay? So this is actin. The red part is actin. Let us see the structure, the particular process of contraction. Completed with that thing, isn't it? Clear with that? What we have to do? Let us see mechanism of contraction. So first and foremost thing, the whole mechanism of contraction starts with a stimulus. We all know what is a stimulus. We'll talk about a stimulus. So stimulus at a neuromuscular junction. Next chapter would be obviously neural control and coordination. They will be studying the thing called as neuromuscular junction. So what is neuromuscular junction? A part where the neuron attaches to the muscle, or the neuron comes in contact with muscle. So whenever there is a neuromuscular junction, there will be stimulus at a particular point, and this stimulus is going to do what? This is going to release calcium from sarcoplasmic reticulum. What is sarcoplasmic reticulum? Sarcoplasmic reticulum is the endoplasmic reticulum of a muscle. Vinny must have taught you what is endoplasmic reticulum. So if you take into account the endoplasmic reticulum of a muscle, of a skeletal muscle, you call it sarcoplasmic reticulum. So there will be calcium ion released from sarcoplasmic reticulum. There will be a lot of calcium ion release. Now this calcium ion binds to troponin. Remember, the troponin was having 3 subunits. Let's go back once again. This thing. The troponin was having 3 subunits. One was binding to calcium, one to tropomyosin, and one to F-actin. Now, this calcium binding subunit of troponin will now bind to the calcium ion. And this binding is going to cause a conformational change in the troponin. You know what is conformational change? Conformational change means the change of an object with respect to its 3-dimensional position. So if it was earlier like this, just look over here, everybody. So if it was earlier like this will turn to become like this. Okay, if it was like this, just take into account, this was like this. This is one of the part of troponin. This is another again a part, and let my head be the third trimer. So this would, if it was like this binds to calcium, and I change my conformation. Okay. This was like this earlier, it binds to calcium, this was somewhat like this, so this will change my conformation. So this section was binding to actin, this was binding to calcium, and this is binding, my head is like, take it to the third trimer, this is binding to the tropomyosin. So what would happen, as soon as the calcium binds to this part, this troponin part, this whole conformation is going to change, and the part which was covering actin will make it free. Okay? Clear? So, troponin undergoes conformational change. That is changes its position and troponin subunit which was binding to actin will make actin free. So the whole aim of this particular conformational change was what? To make my actin free of any boundation. So my actin is now what? My actin is now free. So this kind of conformational change will take place and will make my actin free. So first my actin was bound to troponin. Now my actin is not bound to troponin. Once calcium ion binds to the troponin binding subunit, whole thing conformationally changes. So actin is free now. Now this actin is now ready. So this actin will do what? This forms a cross bridge. With myosin head. Remember this thing? So this was our red section, if you remember. And as I remember, this must be the blue part. This was the blue part. So the blue part was what? The blue part was this was my actin and this is my myosin head. Okay? Clear? Sorted? Isn't it? So this is going to happen now when actin forms a cross bridge with myosin head. So myosin head will form a cross bridge. Clear? Tell me yes, no, something. This is a bit crucial thing. Yes, Tamil Long, Shillong, tell me something, please. Don't you repeat something? This cross bridge part is over, isn't it? Still waiting? Tell me, I'm waiting, children. Okay, very good. Thank you so much. So this actin will form a cross bridge with myosin head. This part up to this now is over. Okay. Now you have two walls in your classroom. Can you see on both either of the sides you have walls? Can you see that? Obviously you can see. Everybody, look over here. Can you see? On either sides, you have two walls. Isn't it? You have walls. Now, if suppose I'm asking you to pull these walls together, that's obviously to make your classroom more narrow, you're going to pull these walls together. Can you? Taking into account, you are having, this is your actin, this is your myosin. Two of your fists are your myosin heads, like this. And your walls are Z-line. Just imagine, on the walls you have chains aligned. on either side of your walls, you have what? You have chains. Just imagine this situation. We'll take this thing. Okay, let's try to draw. This is your class. Okay? Now, just imagine you have chains on either side, and this is you. This is chain. No, you cannot imagine? Yes, the blue part is myosin head. Yes. The blue part is myosin head, which is supposedly binding to actin. This thing. This particular thing. Okay? Clear? So this is you in between. Can you see again? Just imagine these are two walls of your class. And this is your chain attached to it. This is also a chain. And this is you. You are trying to pull the walls together, holding the chain. You want to hold the chain and pull the walls together. Okay? It's the same thing going to happen over here. Now you are nothing but you are myosin. These chains are nothing but these are actin, and this wall is nothing but this is the Z line. Getting my point? And the region in which you are standing is the H zone. Getting it? All of you. Now you try to pull the walls together by moving your fist, obviously holding the chain. Same thing myosin is going to do. Once myosin forms a cross bridge, what they start to do, they start to pull the actin together by moving their head section. So earlier their head part was how? Their head part was something like this. Now when they form a cross bridge, when they start to form a cross bridge, remember there will be ATP breaking. Energy. I told you we'll come back to this equation soon. This energy is used to rotate myosin head. Now this head was like this. This is going to become like this. So if your actin was supposedly over here at one point of time, this will travel, and now you can find this actin over here. Isn't it? And this blue section will be again present over here only, it's obviously binding to actin. Is there any displacement? Is there any difference in the diagram 1 and diagram 2? Can you see this? Can you see this difference in diagram 1 and diagram 2? There's displacement of actin, say from this side to center. Similar way, your wall will also move from the right side towards center. Am I clear? So this whole chain will be pulled. The chain is made up of what? The chain, if you remember, is made up of actin. You are myosin, and Z line is the wall. So what you are trying to do, you are trying to pull the chain, and along the chain, the walls will also come closer and closer. Clear? This will only happen when actin-myosin cross bridge will form. After that only this is going to happen. Yes. Tell me, is it clear, everybody? You're trying to pull it? And this pulling will be only because of what? Only because of the energy when you break your ATP molecule into ADP plus pi. Because you must be aware when bond is broken, energy is released, and when bond is made, you need to put energy. Consumed, energy is consumed. Did you pull it? Did you pull the chains? Yes. Did you? Tell me. Draw one more diagram. Quickly to see if the chains are pulled. So, this is you trying to pull chain. You're trying your best to pull the chains. Yes, you are putting your best efforts. This was green, I guess. I asked you to put more efforts. Yes, put in more efforts. Your myosin. Keep on putting efforts. Succeed. Yes. Yes. Can you see? Can you see over here what the changes are? See. First part, the H zone was very broad. As you proceed to keep on pulling the walls, I told you keep on pulling the chains and the walls will come closer. You can see, I told you earlier also, this distance is what? This distance is called as sarcomere. I told you earlier. This whole distance is what? Between two Z lines. It's called as sarcomere. This is one Z line. This is another Z line. Distance between two Z lines, sarcomere. Now when we were pulling the walls together, what we got is, we got the sarcomere length shortened. Can you see this? The sarcomere is getting short and short. Similarly, your H zone is also getting short, because this is like the area where there was no sign earlier, there was no actin earlier. Actin started to slide over that area. So this H zone is also going to decrease. Sarcomere is going to decrease in its length. Then let's see I band. This was the I band region where there was no myosin. This I band is also going to decrease. Okay? And what about A band? Since the A band was the area where only myosin was present. Only A band will remain constant. So this kind of questions are very much asked at what are the changes, since A band was the region where was myosin present. So myosin remained at its position. You were always there at your position, and you tried to pull the chains together, keeping your H zone minimum. So you started to slide the actin or the chain into your H zone. This is your H zone. So you are trying to slide the chains into the H zone, and thus you are making the contraction process possible by bringing together sarcomeres more close. Sorted, all of you? This is head rotation of the myosin. The head rotation of the myosin was brought about by breaking of ATP, if you remember. Because when you break a bond, you release energy. When you make a bond, you consume energy. Sorted? Copied? Okay, fine. So let's again see what is thing going on. So actin forms a cross bridge with myosin head. Then what happens? Energy is released And this energy is used for what? This energy is used for rotation of the myosin head. So we'll continue from this thing. So actin only moves. Actin slides over myosin, but myosin remains constant at its position. So it's actin which is actually moving, not the myosin. Myosin will remain constant. You will remain constant while pulling the chains and the Z line. Okay, you are not going to move from your place. You just pull it this way. Now once you do, just look at my feast position, feast movement. So when you are pulling it like this, okay, when you are pulling the walls, just imagine the screen are the two walls for me. So when you are pulling the chain, the imaginary chain, your fist was like this, okay, something like this. Now you're going to rotate it and pull it like this. You're pulling it. Okay, I guess this is somewhat inclined. I'm sitting in an inclined position. So this is I'm rotating my fist. Can you see this? So I'm just pulling it towards myself. It is pulling it. This is one of the contraction movements. There will be many contraction movements, one after the another, to process the whole structure or whole process of contraction. This is just one contraction. So one contraction is going to pull the actin, the imaginary chain, and bring it like this. Once this rotation is over in a way, we started with this structure, we'll resume again. So once this particular thing is over, okay, once you have pulled it towards inner side, this was actual side, now you're pulling it towards inner side. Once you have pulled it towards inner side, the energy is consumed. Now you are done with the particular process, you want more food. So energy is consumed. What will happen? Rotates and pulls actin over myosin, and then we will start with the next phase. Actin myosin cross bridge, because you have consumed your energy, so you need more energy. For time being, this particular thing of cross bridge will break. So your actin myosin cross bridge dissociates, and what happens after this? ATP binds to myosin head. Over here mentioned contraction of muscles. This cross bridge formation will do what? It will help in contraction of muscles. And then you have is next phase. This is relaxation of muscles. So two phases. Once ATP is broken, contraction will take place. Once ATP is binding back to myosin head, the relaxation will take place. Once relaxation takes place, the calcium ion will unbound. Calcium also dissociates from troponin. and calcium ion moves back to sarcoplasmic reticulum. So if you need to have more contraction cycles, you have to process this whole step again. So if again you have again another contraction cycle, so you will start away again from this step, again from this thing. So if you are writing continuously, I am writing continuously, there must be many contraction relaxation phases going on at a single time. That is the reason why we can write, we can like do different kinds of activities that involves these skeletal muscles. So this whole process will be repeated again, no matter how many times it is done. Obviously, you need to have energy for that because ATP, you know, ATP is processed in mitochondria when glucose is broken down. So you need to have energy for this whole process, and this energy is used in form of ATP, and ATP is again broken down for contraction. When it attaches to myosin, it brings about relaxation. So keep this thing in mind. The whole cycle is complete. I will be sending you a video, so you can go back to your place and see that video on your mobiles. I know many of you don't have mobiles in class, so I will be sending you a video later onwards. You can just refer to it. Or in case if you are here also with mobile, I will be sending you now only. Yes, did you get it? If you have access to your mobile, you can just see them. Okay. Fine. So I'm just proceeding ahead. Do we have any doubts up to this? So muscle contraction, relaxation is done now. So when ATP binds to it, we have to have a relaxation phase. When ATP is broken, we have to have a contraction phase because the ATP when broken releases energy, and that energy is used to move the myosin, isn't it? To rotate the myosin head and pull the actin chains in the H zone, in the region where already there was a gap, there was no actin. So actin slides over the myosin. This particular theory is called as sliding filament theory, this whole thing. This particular thing, this whole diagram where I showed you that this is the particular structure, this was having H zone which is very, very broad, and then it gets on being narrow and narrow. This is called as sliding filament theory. Okay? Clear? Sorted everybody? All of you? Yes, children? Tamilong, Shillong, tell me. Sorted? Can I move to a new topic? Shall I? Okay, I'm starting a new topic since you are not telling me anything. I take it for granted you are clear with this. Shall I? Okay. So talk about joints now. So muscle contraction things are over. So you know, in between your bones you have joints, isn't it? That should have been taken by me in the last class itself, but I did not. So I'll be talking about joints and disorders, only two topics now. Joints. So we classify joints under three categories. Sliding filament theory is basically a theory which tells you about that actin slides over myosin. This is actin sliding over myosin. This is sliding filament theory. Can you see this? This blue structure was over here earlier. It has started to slide and it has come to this section. This is called as sliding filament theory. So when you're pulling chain, the chains are coming to the center. They are sliding over the myosin. Okay, this is called as sliding filament theory. Clear? So what are joints? Joints are the points of contact in between the bones, isn't it? So on the basis of the type of joint, whether movement is possible or not, we will classify joints into three different categories. The first is the fibrous joints. Okay, these fibrous joints are allowing no movement. There is no movement in the fibrous joints. Where are they present? This type of joint. These are present in skull bones. To form cranium. In the last video, you can just refer to the skull bones. I have taught you all those things. Just let me know in case something is not clear. And then we have is cartilaginous joints. What are cartilaginous joints? They allow slight movement. The examples are vertebrae, bones or vertebral bones of vertebral column. So you can see the last video where we have 26 bones in the vertebral column, and all the vertebral bones, the vertebrae, are attached to each other by means of cartilaginous joints, which allow slight movement, very little movement. Third category we have is synovial joint. The synovial joint is said to be the most movable joints. Fluid called as synovial fluid is present that allows maximum movement. Okay? So these are the joints which are obviously most helpful when we talk about movement and locomotion. The first type of joint is called as ball and socket. This is present in your humerus and pelvic pectoral girdle. This kind of movement, this particular movement is because of ball and socket joint. This is basically present between humerus, one of the examples, and pectoral girdle. This is your pectoral girdle, this is your humerus. Okay, next is, next kind of synovial joint happens to be the hinge joint, H-I-N-G-E. Hinge is a particular structure which is present at your doors also, which allows only one side movement. So this particular joint is hinge joint. I cannot move my elbow downwards. I can only move it upwards. Same thing is with knee joint also. You can always bend it towards your back, not towards your stomach or your face. This particular joint is called as hinge joint. This allows movement in one plane. Example you have is elbow and knee joint. Then you have is pivot joint. These are subtypes of synovial joint. Between your atlas and axis. Now, atlas is your first vertebrae, axis is your second vertebrae. This particular thing on the cervical. So this allows this particular kind of movement. Yes, no movement. Yes, movement. This particular movement, nodding of your head, is because of pivot joint. Then you have is gliding joint. These are present between carpals. This particular movement. When you are waving your hands, this particular thing, these are particular bones called as carpals. Carpals are nothing but they are the wrist bones. These bones are called as carpals. So when you move your hands like this, okay, when you want to hit somebody, just show your hand like this and then you hit him. So this is particular structure is because of gliding joint. It's present between the carpals. Then you have is saddle joint. Between carpals so these are your carpals and these are your metacarpals. These particular structures on your palm are called as metacarpals. So this particular kind of movement, if you are having this movement, bye, hi, this movement is basically because of saddle joint. So one bone sits in the gap of other bone. This is called as saddle. Okay. And finally you have is, I guess we are done with all the joints. Yes, we are done with all the joints. So these are the 5 different types of joints we are having in synovial joint. Okay. Ball and socket, hinge, pivot, gliding, saddle. Done? Quickly we will move on to disorders. Not much to think about. Disorders are very, very easy. So first disorder is myasthenia gravis. It's myasthenia gravis. So this is an autoimmune disorder. Autoimmune means when your body is not able to differentiate between self and non-self. It starts to attack self cells also. This is you are going to study in 12th standard in more detail. Autoimmune disorders, I will be teaching you all that. And these autoimmune disorders, what they do is that this particular autoimmune disorder, this affects the neuromuscular junction. If you remember, I have taught you what is neuromuscular junction just now. The junction between the neuron and muscle is said to be neuromuscular junction. Okay? And this leads to what? This leads to paralysis, this leads to fatigue, this leads to weakening of muscles. Number 2, we have muscular dystrophy. See, dystrophy means destruction. What is dystrophy? This is degeneration of skeletal muscles. When I was teaching you contraction of muscles, I told you there are continuous adjacent cycles, continuous alternate cycles, contraction, relaxation, contraction, relaxation, contraction. Now what if there is no contraction, relaxation, contraction, but instead there is contraction, 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 contraction. This kind of particular thing is called as spasm. Rapid spasm, or we could say continuous or continued contractions without any relaxation in between. Due to low calcium level, this is called as tetany. So whenever there is low calcium level in our body, what happens is instead of contraction, relaxation, contraction, relaxation, our muscles start to do contraction, 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 contraction. This is called as tetany or rapid spasm. We have arthritis. This is very common nowadays. This is inflammation of joints. The joints become swollen. Fifth is osteoporosis. Since childhood we are knowing what is osteoporosis. Obviously this is basically decreased calcium in bones, and obviously the bones become weak. Sixth and last disorder, gout. What is gout? This is inflammation of joints. And because of what? Because of uric acid accumulation. Clear? All of you? Shillong, Tamenglong, sorted? Disorders are clear, types of joints are clear, muscle contraction must be clear, the structure of actin myosin also must be clear. Okay, ready for assignment? Assignment, today's assignment? Yes. Just giving you 2 questions for today. First question is, briefly explain the structures with diagram of first actin, second myosin. Quite easy. Next question. You have to explain in your own words, okay? Explain the mechanism of, you can take the help of flowchart, yes, but you have to write in a way where you are going to write, as in you are going to write in your exam. Explain the mechanism of muscle contraction. Whole mechanism. This is a long question. This would be for a 5 mark. This would be for, let's say, 3 marks. Half marks, 1.5 marks each. Clear? So these are 2 questions you have to do for today's class. Okay. Do we have any doubts? Shillong, Tamilong? Yes, children, do we have any doubts? Class is clear? We're clear with everything? I gave you 2 assignments. Please try to do them, and if possible, send it on the WhatsApp group. Okay. I guess we are clear with all these things. Okay, fine. Okay. Want to study more, or shall I wrap up? Want to study more? Yes. Want to study more? Okay, fine. Yes, children? No, ma'am? Okay, fine, no issues. So we'll wrap up today with this chapter. This chapter is over from my side. You go back home, please, and read from your textbooks. Whatever problems you are encountering, just let us know. Let me know, obviously. You can talk to me on WhatsApp group. Always I tell you these things. You can talk to me on WhatsApp group as well as in the next class also. Please refer to the video of the last class. That was a skeletal system whole discussed in a single video. That is very, very important for this chapter. And let me know if you have any doubts. Okay, fine. Bye-bye. Time to leave. Yes. Okay, take care. Good night. Thank you so much.